Right, we're going to look at some geometric proofs. So starting with number 1, it says to show that the exterior angle equals the sum of the two interior angles, and we're asked to show that angle DCB, so that's that one in there, is equal to angle CAB. We're going to call that little a, plus angle ABC, we'll call that little b. And just to help us, we might start by calling that one little c. Remember, you can call the angles any letters you like. Right, so if we begin with the top angle up here, angle C, if I knew these two here, A and B, I'd need to go 180 minus A and minus B, and that would give me angle C. So we'll write down the angle C equals 180 minus A minus B, and the reason is because angles in a triangle sum 180. Check you understand that. Now this angle here that we're asked to show is equal to something, I would find that one by using angles on a straight line with C. So this angle in here, we'll keep calling it DCB because that's the official language we're asked to find. Angle DCB. That equals 180 minus angle C. And the reason is angles on a straight line sum 180. Right, so nothing hard about that so far. So that means that angle DCB equals 180 minus, now instead of C we could substitute this expression here, angle C, from the first line up above here, equals 180 minus A minus B. I'm doing a little bit of algebra on this. I can see I've got 180 minus 180. They'll cancel each other out. Now this is a negative times negative A. Two negatives there will make that positive A. And similarly, a negative times negative B. You can think of this as negative 1 in front of the bracket if you like. But we know that two negatives, when you multiply and expand out the bracket, would make it positive. And what we'll do is we'll just go back and use the language that they asked us to use. So angle A over here, we can call that CAB. Plus, and I probably should have used capitals there so it looks like what they're asking for. And then they've talked about ABC, which is our little b. So we'll just go back and use the capitals like they have. And that's the end of my proof. So we've shown that the exterior angle over here is equal to the sum of the opposite two interior angles, which is quite an important proof. Okay, question 2. ABC is a parallelogram, I can see that. Two pairs of parallel sides. Prove that x and y are the same and A and B are the same. Well, we'll just start with one of them. Now, always with parallel lines we've talked about extending the parallel lines to make them obvious, so let's just start with that pair. And I can see that x is going to equal 180 minus A, and that would be co-interior angles. Those are co-interior angles between the two parallel lines. Co-int angles and parallel lines sum 180. Alright. Now if we take the other pair of parallel lines, here's another pair of parallel lines, I can tell they're parallel because I've got arrows on them. I can see that y would equal 180 minus A, because they're co-interior inside the second pair of parallel lines, so it's the same reason. Co-int angles, parallel lines, sum 180. And therefore you can see that if x is 180 minus A and y is 180 minus A, we can just write a therefore arrow x equals y, as we're asked to do. And a similar proof will show that A equals B. It says this is an important result. It shows us that opposite angles in a parallelogram are equal. so we could use that result now we've just proved it. Alright, moving down to number 3, we're asked again to prove that x equals y. I just need an intermediate angle. I think we'll use this one. I'm going to call it z, and I can show that y equals z because they're vertically opposite angles. Vertically opposite angles are equal. Alright, and I can also show that z and x are equal. And the reason they're equal, they're within these parallel lines here, corresponding. This position here corresponds to this one. So we've got corresponding angles and parallel lines are equal. Once again, we need a therefore arrow. If y is z and x is z, then of course y must equal x, as we're asked to show. Okay, and similarly with part B here, proving that x and y are the same. I think I'll start with this little angle here. I'm going to call it little c. And there's a pair of parallel lines. We'll extend them. So I know that x and z are going to be the same because they're in a corresponding position to each other between those pair of parallel lines. So we can write that x equals c, corresponding angles and parallel lines are equal. Alright, and now I can see that c and y are the same because there's another pair of parallel lines here with more arrows on them. So once again, c and y correspond to the same place within this pair of parallel lines. So y equals c, corresponding angles and parallel lines equal. Once again, with a therefore arrow, if x is c and y is c, then x and y must be the same, as we were asked to prove. And the last one on this sheet, we're given a pair of parallel lines. We could make those longer, which is the technique we've been using. And we're asked to show that a plus b equals c, which is not immediately obvious. I think we're going to need to find some other angles in here. I can see within the parallel lines, and here is my transversal cutting through, that this one and this one are clearly the same because they're alternate angles within that pair of parallel lines. Now we need to call this one here something, ABC. How about we use an x? So I can write that A equals x, and the reason is alt angles and parallel lines are equal. We've got angle B there. Now that would mean that this angle in here, once again I need to call it something, so I'm going to call it y. Y would equal 180 minus x minus b, angles in a triangle, sum 180. And then to find c, c is going to equal 180 minus y because they're on a straight line. 180 minus y, the reason being angles on a straight line. Sum 180. And now we need to do some algebra on this. So instead of writing a y, I can put in 180 minus x minus b, because y is the same as that expression. And once again, similar to before, 180 minus 180 will cancel out. Now that negative 1 in there times negative x will be a positive x. That negative 1 expanded into the negative b, two negatives, change the sign, makes it a plus b. I'm almost there. I was asked to prove that c was a plus b. Now fortunately up here we have the fact that a and x are the same, so I can replace x with an a plus b as we were asked to prove. Of course there are many other ways, and we could have used the rule from above about the exterior angle being equal to the sum of the opposite two interior, which would have saved us a lot of work. Whatever you find easiest.